All right, folks, another week, another chapter. This chapter 11 is on areas. So all the shapes we've been talking about all year, we're just going to find the areas. And, you've been through a couple of those in your lifetime, like squares and rectangles. And I'm sure you even know triangles already. So some of this should be a review for you. Each of these has their own formula. For instance, as you look at the square, they say s squared. Each side is, of course, the same length. And to find the area, you just multiply one dimension. This is the left and right times the up and down. That's kind of the same as a rectangle, except on a rectangle, the two sides are different. So that's why they have two different values here. But they're essentially the same equation. Length times width gives you the area. Again, now on triangles for me, I'll skip the parallelogram for now, but you guys are probably familiar with the triangle. You do the base and the height, and you take 1/2 of that. And just so you know, why is that 1/2? Because basically a triangle, no matter how it's shaped, is always going to be half of the rectangle that it fits inside of. So this space in here and this space over here together would be equal to the area of a triangle. No matter how you changed, this top point up here, it would always be half of that rectangle. It's kind of a neat little feature of triangles. And the fourth one here is parallelograms. And all you need for this is, it's like a rectangle again. The base times the height. And again, because this area and this area will be half of the rectangles that are represented by the diagonals there, it all comes out to be basically a rectangle. And if we were in class, I'd spend more time explaining that to you, but we're not, so I will not. A couple of quick examples for you, and just let you guys do some problems then on your own. Looking at this shape here. Again, you have to be careful what they're giving you here. You need the full length, the length for this parallelogram. You need the full base and full height. So you almost have to turn it sideways. Your length is here and here, and they're equal. And the value they gave you there, if I can show you that again quick, is the 12. Okay. And the height they gave you is this 4. So they're trying to fake you out with this 6 and this 8. All you need is a 12 and the 4. So again, here's the formula for parallelogram B and H. So A equals B times H. And that's just 4 times 12. So A equals 4 times 12. A equals 48. The units here, they don't even give the units. Okay. Here is again, they want us to find perimeter. We're just going to find the area of the triangles. Again, our base is this, our height is this, and it's 1/2 of that. So the area of a triangle is 1/2 base times height. So A equals 1/2. Height is 8. The base is 21. And what I like to do is, when I see a half, I take a half of that 8. That's going to give me a 4. So A equals 4 times 21, or 84. Okay. What else we got here that's new? I'm looking for a rectangle or a square for you for examples. Oh, those are so easy, huh? Yeah, there aren't any other examples because they're pretty much easy. All right, your homework's going to be these 6 problems here, but I'm going to give you a hand here. It's 3 through 8. Now, this number 7 here, again, they give you the height here, but they didn't give you the base. And this is a right triangle. And if you remember, I don't know if you do, but we had those shortcuts, Pythagorean triples for finding side lengths. I know if I can divide each of these by 6, I'll have 5, and I'll have 3, and then the 3, 4, 5 triangle, so this would be a 4, and times 6, all those numbers. This side here is 24. So as you're doing this problem, my friends, I know I just kind of did this quickly for you, you need that number there also, the 24. So as you're trying to calculate your area, here's your base, and here's your height. And then you have those 6 problems. Now, also, we have this. We're going to be doing with you some other shapes we had. We had these shapes as well. Trapezoid, again, here's the formula for the area of a trapezoid. It's 1/2 height times the B1 plus B2. So these are your bases. Here's your base right here. Here's your other base, and here's your height. Okay, so just plug in the formula to find the area of a trapezoid. Here's an example for you we'll do with you real quick. Although I don't have a calculator, so I'll just show you how to set it up. So again, the values I have here are, here's my one base, the 3.6, here's the 6, and here's the h, the 5.8. So just make sure you stick them in the right place on the equation. So the equation above is a equals, it's 1/2. The height is the 5.8. I'll put in parentheses 5.8. And then the bases are the 3.6, 3.6. Again, they're added. Again, if you look at the formula, they're adding the two bases. So 3.6 plus the 6. And going forward here, I think 1/2 of 5.8, that's going to be 2.9. So A equals 2.9, and 3.6 times 6 is going to be 9.6. So with a calculator, you can multiply 2.9 times 9.6, and you have the area of the trapezoid. Just make sure, folks, as you're doing these problems, you add these first, then multiply by the height, and then the half. The other shapes I got here for you are the rhombus and the kite. And what's nice about these is they're the exact same formula. So let me zoom in on here for these. The rhombus on top, again, all four sides are equal, right? And then you just take the diagonals, multiply diagonals, and then times half. Well, same with the kite. You have diagonal here, and the formula is exactly the same. Multiply diagonals times a half. So I'll do an example of that for you as well, if they have one here. And here we go, it's a guitar. This rhombus, PQRS, represents one of the inlays in the guitar. Find the area. So we have diagonals here of, oops, I don't know what I just did there. They have area, an area, yeah, diagonal 9 and diagonal 12. So here's your 9, here's your 12. So the formula is A equals 1/2 D1 D2. So A equals 1/2 times 12 times 9. Again, 1/2 of 12 would be 6, right? So you have A equals 6 times 9. That's 54, in this case, millimeters. And that's how you do all those. And then I'll be giving you a couple problems down here to do as well. All right, folks, have fun.